Design tables can be used to quickly create large numbers of configurations as well as update and manage them. In parts like nuts and bolts, you may have hundreds or even thousands of parts. Design tables will allow you to create those quickly. In this case, we'll be creating a hex nut and we'll be creating multiple configurations within a design table. To start out, we need to create a sketch on the front plane, and then we'll use the polygon tool to create a hex. Make sure this is set to 6 sides, and I'll draw that in at the center, and then we'll give that a dimension of 1/2 inch. And then we want to set 2 of these points as vertical. Next, we'll add a circle to the center and give that a dimension of 5/16. And then we'll create an extrusion from the profile. And that's going to have a height of 17/64. For this part, we won't be adding the schematic threads, but we will be adding a chamfer to both sides of the edge. So we'll go ahead and choose the chamfer tool and the inside cylinder. And we're going to use the distance option and set these both to 0.025 inches. Next, we'll go back into the Features tab, and if your Instant 3D is currently turned on, you just want to turn it off. And then right-click into the Annotations folder and choose Show Feature Dimensions. We're going to use the design table to update the height, the width, as well as the through hole. And we don't want to have to bother with updating the chamfer each time. So we're going to go ahead and add equations that are defined based on dimensions that we already have here. So first, I'll choose the width dimension of the chamfer, and double click, and choose Add Equation. Then I'm going to go ahead and select the width here. And I'm going to divide that dimension by 20 to retain the 0.025 dimension. Next, I want to double click on the height. Add equation once again. And I'm going to connect this to the through hole this time. And for this dimension, to retain that dimension of 0.025 inches, we'll have to multiply by 0.025 and divide that by 5/16 and click OK. Now that we've automated our chamfer dimensions, the last thing we want to do before creating that design table is change our dimension names. You can see if I hover over the dimension, it shows D1 at sketch 1 underneath. I want to click on the dimension and come into the property manager on the right, and inside the primary value tab, change this to width. And we'll go ahead and change this name to diameter. And we'll change the height D1 to height. Changing the dimension names isn't entirely necessary, but it's going to be very helpful when we're working in the design table. It's a lot easier to figure out what width means than D1 at sketch 1. And you'll see that when we create the table. So the next thing we'll do is go into Insert, Tables, and choose Design Table. We want to keep the default of Auto Create, and don't worry about the other options here. Just go ahead and click OK. And it's asking what dimensions we'd like to select for the design table. We want to hold down Control and select all 3 and click OK. You can see that now that opens up a new window and brings in that Microsoft Excel interface. If nothing came up for you, or if you're not seeing this, you may not have Microsoft Excel installed, and you would want to go ahead and install that. Looking at the design table itself, we can see that it brought in the name, those dimensions as well as the values corresponding to this configuration. To add a new configuration, all we have to do is type in a new name and give it values. Our first new configuration is going to be 1/4 inch hex nut. Then we're going to add in 1/4 inch heavy hex and a 1/4 inch jam nut. Now when putting in a value for the configuration, you might be tempted to put in 1/4 of an inch. And while this looks fine within the design table itself, this actually isn't a valid name within SOLIDWORKS. So you'll want to actually use either the 0.25 or come up with a different way of representing it yourself. But once again, that fractional form won't work. So I'll go ahead and add in values here. The diameters of these three are all 1/4 of an inch. The width of the first one here is 7/16. The heavy hex is 1/2 of an inch. And the jam nut is 1/2 of an inch as well. The height of the 1/4 inch hex nut is 7/32. The heavy hex is 15/64. And the jam nut is 11/64. Once you're done entering in those values, all you have to do is click outside of the table into the workspace. And you'll see this message comes up. The design table has generated those new configurations. If we go back into our configurations tab, we can take a look at the new configurations. You can also see that these chamfer values update based on the values of the diameter as well as the width. Next, I want to add in 3 configurations for 5/16 inch hexes. So the first thing I'll do is delete out the default configuration. And any configuration deleted from the configurations tab is also going to delete out of the table. We also have the option of editing the table in Excel itself just by selecting that edit in new window. I'll go ahead and add in the 5/16 inch nuts. And I'll go ahead and enter in those diameter values of 5/16. The width of the hex is 1/2 an inch. The width of that heavy hex is 9/16. And the width of the jam nut is also 9/16. The height of the hex is 17/64. The height of the heavy hex is 19/64. And the height of the jam nut is 13/64. To update these changes, we'll go ahead and just save the Excel document and exit out. And that'll automatically add in those 3 new configurations. Lastly, we're going to add in configurations with a washer on one side of the nut as well. So I'm going to go ahead and click on one of the hex faces and create a sketch and just draw in 2 circles. Then we'll add in dimensions. And the dimensions themselves don't matter, as we'll be adding equations to the dimensions. For that inside diameter, we'll go ahead and add an equation and choose the through-hole diameter. And we're just going to increase the diameter by 10% by multiplying by 1.1. And for the outside diameter, we'll also add an equation, choose the width, and I'll go ahead and multiply that by 1.3 to increase that diameter by 30%. Then we'll go ahead and extrude the washer. And once again, that dimension doesn't really matter because we'll be setting that with an equation. For this equation, I'm not going to use the height of the hex because that varies with the same diameter through separate configurations. So I'll go ahead and choose that inside diameter, the one dimension that doesn't vary. And we'll just divide that by 10. And click OK. Now the suppression state of a configuration is also something that can be controlled through a design table. So we'll go ahead and go back into our design table. Go into the Features tab. And in this box, I'm going to go ahead and double click on the Boss Extrude. And that'll bring in the suppression state of the washer. You can see it came in by default as unsuppressed. You can either have unsuppressed or suppressed. You can also have U and S for unsuppressed and suppressed. In this case, we're going to set these all as suppressed. Then I'm going to go ahead and select out these rows and columns. Do a Control-C to copy. Click in this cell below and paste that in. Now I'm going to go ahead and update the names at the bottom. Just add a W for washer at the end of all of these. And I'll add a U for unsuppressed for those 6 configurations. Now we can see that 6 more configurations were created. Half with washers, and half of our configurations don't have the washer. So now you can see that design tables can be used to quickly control configurations. So go out there and create some parts using design tables.